Welcome. Today we explore absolute value inequalities. Remember, absolute value represents the distance a number is from zero on the number line, regardless of direction. This fundamental concept is the key to unlocking more complex algebraic transformations. In engineering and science, we use these inequalities to define safety margins and tolerances. Whether it is the thickness of a steel beam or the voltage in a circuit, absolute value helps us define acceptable ranges of error. Because absolute value measures distance, the result is never negative. When we solve inequalities, we must account for the two different directions on the number line that satisfy the distance requirement. When the absolute value is less than a number, we are looking for values close to the origin. This creates a conjunction, or an and statement, where the solution is bounded between the negative and positive limits. Conversely, greater than inequalities describe values far away from the origin. This results in a disjunction, or an OR statement, representing two separate regions on the number line that extend toward infinity. Graphically, the expression x minus h shifts the vertex of our absolute value graph to the point h. The inequality then asks us to find where this V-shape sits above or below a specific horizontal boundary. Multiplying the absolute value by a constant scales the graph. A value greater than 1 makes the V narrower and steeper, while a fraction between 0 and 1 makes it wider, changing how quickly the distance grows. Before splitting into two cases, you must isolate the absolute value symbol. Treat the entire absolute value expression like a single variable. Add or subtract constants and divide by coefficients until the absolute value stands alone. Let's solve x minus 5 is less than or equal to 3. We set up a sandwich inequality. By adding 5 to all sections, we find that x must be between 2 and 8, inclusive. Notice the closed circles on our graph. Now for a greater than or example. We split 2x plus 4 is greater than 10 into two separate inequalities. Solving each independently, we find that x can be less than negative 7 or greater than positive 3. The visual representation clearly shows two disconnected rays. This confirms our OR logic. Any number picked from these shaded regions will satisfy the original inequality, while numbers in the middle will fail. Watch out for negative coefficients. If you divide or multiply by a negative number to isolate the absolute value, you must flip the inequality sign. Forgetting this step is the most common error in algebraic transformations. Sometimes, there is no solution. Since an absolute value is always 0 or positive, it can never be less than a negative number. If you see x minus 5, you can immediately conclude the solution set is empty. On the flip side, if an absolute value is greater than a negative number, the answer is all real numbers. Since any distance is at least 0, it will always satisfy being greater than any negative value. To summarize, always isolate the absolute value first. Use and for less than signs to find the intersection, and OR for greater than signs to find the union. Always check if you need to flip the sign during isolation. Let's test your knowledge. Solve the inequality x plus 1 is less than or equal to 4. Think about the distance from minus 1. The correct interval should be between minus 5 and 3. Did you get it right? Mastering absolute value inequalities allows you to solve complex real-world constraints with confidence. Keep practicing these transformations and always visualize the number line. Thank you for learning with us. Generated by Vision Solve AI.